A few years ago, humanoid robots were mostly expensive experiments. They could walk across a stage, lift a box, or perform a carefully rehearsed demonstration. But something has changed. Unitree says it shipped more than 5,500 humanoid robots in a single year. Figure says it has accelerated production from one robot per day to one every hour. And inside a real commercial warehouse, Agility Robotics Digit has already moved more than 100,000 containers. This is no longer a competition to create the most impressive demonstration. It is becoming a race to manufacture a new kind of worker. A machine designed to walk through the same buildings, use the same tools, and perform many of the same physical tasks as humans. The question is no longer whether humanoid robots can walk. The question is whether they can become useful, reliable, and affordable enough to work beside us. Because the most important machine of the AI era may not be a chatbot. It may be a body, but a body alone is not enough. Humanoid robots have existed for decades. What changed was not the idea of building them. It was the technology required to make them useful. Modern vision systems can now identify objects, estimate distance, and understand movement in complex environments. Large AI models can interpret instructions, break tasks into steps, and adapt when the world does not behave exactly as expected. At the same time, electric motors became smaller and more precise. Sensors became cheaper, batteries improved, and simulation allowed engineers to train robots through millions of virtual experiences before placing them in a real factory. The biggest change, however, may be how these technologies now work together. A camera is no longer just a camera. It becomes part of a system that can see, decide, and act. A robotic hand is no longer following a single program motion. It can adjust its grip, respond to resistance, and try again. This is why factories and warehouses have become the first proving ground. They are structured enough for robots to operate safely, but varied enough to test whether those machines can become genuinely useful. And once humanoid robots began moving from controlled demonstrations into real workplaces, the race changed. It was no longer only about research. It became a competition between companies to build the platform that could define physical factories and warehouses may be the first proving ground, but they are unlikely to be the final destination. Because the real advantage of a humanoid machine is not that it can work inside one specially designed facility. It is that it may eventually move through the world we have already built. Consider an airport. Its doors, elevators, corridors, baggage systems, and service equipment were all designed around the human body. A machine that can walk through those same spaces, carry ordinary equipment, and use existing tools would not require the airport to be rebuilt around it. The same idea could extend much further. In a school, a humanoid robot might prepare a science laboratory, move equipment between classrooms, or handle repetitive physical tasks while teachers focus on students. In a commercial kitchen, it could carry trays, organize supplies, load cleaning equipment, and keep workstations operating between busy service periods. And on city streets, machines with human-like mobility could support maintenance crews, move safety barriers, inspect infrastructure, or carry equipment into places that are dangerous, exhausting, or difficult for people to reach. These are not promises that every home, school, or airport will soon be filled with robots. The technology is not ready for that, but the direction is becoming easier to see. The factory teaches the machine how to work. The wider world tests whether it can become useful outside a controlled environment, and that is where the humanoid form begins to matter. The world was not redesigned for robots. Humanoid robots are being designed for the world we already have. A world of stairs, doors, tools, kitchens, classrooms, terminals, sidewalks, and people. If these machines become reliable enough, the next generation may not think of robots as unusual visitors from the future. They may see them as another kind of machine that simply belongs in everyday life. But before that happens, one question must be answered. Who will build the robot that gets there first? If humanoid robots are finally becoming practical, then one question matters more than any other. Who will build them first? Around the world, technology giants, ambitious startups, and robotics laboratories are racing toward the same goal, building the world's first truly useful humanoid robot. At first glance, many of these machines look remarkably similar. But beneath the surface, each company is making a very different bet. Some believe that manufacturing at massive scale will determine the winner. Others believe intelligence will matter most. Some are focused on reducing cost. Others are solving real industrial problems today. And some are designing robots that can work naturally alongside people. Every company believes its strategy is the right one. Only reality will decide. Building one extraordinary robot is an engineering achievement. Building 1 million reliable robots is an entirely different challenge. The race is no longer about building a robot. It's about building an industry. And that is where the real challenge begins. Every impressive demonstration eventually comes to an end. But that is where the real story begins. A humanoid robot is not judged by a perfect performance on stage. It is judged by what happens on an ordinary Tuesday morning, inside a real factory. Can it keep working for hours? Can it recover from failure? Can it operate safely, beside people, day after day? Because building a remarkable robot is one challenge. Building one the world can depend on is something entirely different. Technology has always changed the way people work, not by replacing everyone, but by changing what people do. Humanoid robots may take on repetitive, dangerous, and physically demanding tasks, but every robot will still require people to design it, to train it, to maintain it, and to decide where it should and should not be used. The future will not be built by humans alone, and it will not be built by robots alone. It will be built by both. The first generation of humanoid robots will not transform the entire world overnight. Their journey will begin quietly. One warehouse, one factory, one production line. Then, little by little, their role may expand into hospitals, construction sites, disaster response, critical infrastructure, and perhaps one day, places where sending a human is simply too dangerous. The future will not arrive all at once. It will be built, one successful task at a time. For decades, we imagined machines becoming more human. But perhaps the real achievement was never about building a machine that looks like us. It was about building one we can trust, because the future will not be defined by the robots we create. It will be defined by the choices we make.